Okay, we just did matrices. Now we're doing data structures for arrays and factors. So remember that a matrix was a had two dimensions, and if we want to generalize, we can have more than two dimensions. We can have three dimensions or more. So we can make a vector like that, and we can then take the vector's dimension attribute and assign it. Now before we did an assignment like C23, and now we're giving three dimensions, C232, and then we can print the vector. We can print the result, and we get this. So first of all, let's what did we do? We made a 2 by 3 by 2. So let's look at what we get when we print it. So what does it show us? It shows us here we're specifying the 1 in the last dimension, and here 2 in the last dimension. There's only 2 in the last dimension, so it's either 1 or 2. So this is when we have 1 in the last dimension. So we have like one slab which says 1, 2, 3, 4, 5, 6, and then a second slab which says 7, 8, 9, 10, 11, 12. And this is because it's not possible to print three dimensions on two-dimensional screen. So the discussion of matrices can be generalized to three dimensions or even n-dimensional structures. Just assign more dimensions to the underlying vector or list. The following example, we create a three-dimensional array with these dimensions. So that's what we did here with these dimensions. And note that R prints one slice of the structure at a time. Okay, now special note here. We've been saying that matrices have to all have the same type of mode for all the elements, but actually if you take a list which doesn't have to have the same mode and you just give it a dimension, it will be treated as a matrix. And even if it is even if it's heterogeneous, even if there are mixed modes. Let's see that. So here we have a list, and it's mixed mode, and we'll give this list dimension, and then print it. And you can see that it's a matrix now of mixed mode. So this is a little bit odd, but and we're going to try and avoid these kinds of situations. Okay, let's talk about factors. Factors are basically just like vectors, but they have some special properties. So remember that you can have vectors that are numeric, and you can have vectors that are not numeric. And a factor is like a non-numeric vector, but it has some special properties. So R keeps track of the unique values in a vector, and each unique value is called a level. So you might have a vector like this: A, B, B, D, B, B, A. So you could ask, how many unique values are there? Well, BB occurs twice, so we say uniquely there's only one. So how many other? There's A, there's BB, there's D, and that's all. Okay, so that's what we mean by unique values. And R keeps track of the unique values in a vector, and each unique value is called a level of the associated factor. So if you're treating this as a factor, the levels will be A, BB, and D. R uses a syntactic representation for factors which makes them efficient for storage in data frames. In other programming languages, a factor would be represented by a vector of enumerated values. And there are two key uses for factors. One is for categorical variables. A factor can represent a categorical variable. Categorical variables are used in many places. And for grouping. And we have some videos about grouping in this series.